Hello and welcome back. Yes, I found another one. I have another Keithley that I didn't have, and this time it is the 168. It's also auto-ranging, and it is again one of the first, just like the 167 I had before. That was very special because it is a probe multimeter, but it was already auto-ranging, and for this one it is exactly the same. And my guess would be that it is around 1974 that this one was produced. And that makes sense because the other one was from 72 or late 71. And well, it's also auto-ranging, which is great for that time. And I see they took two buttons out, but I do already understand why. So let's have a closer look. Okay, the 168, here we have it. The whole front is like a red transparent, like you usually only have in front of the display. But here it is just everywhere, it's all transparent. If you put a light on it, you can see already, you can almost see through. So we need to clean carefully. Here are two buttons, and it is the charge button and the battery button. Both are disabled, and I think I know why, because they don't want you to use it, because I think the batteries are out, it's not that heavy. And why they use this method? Well, I think it is because it was used in a school. And oh, it's yes, it came from the US. So I need to switch it over to our local. Can we do that? Yes, we can do that. Between 210 and 250, so we can try to do that. Well, it is from the US, so I need 110 volts. It was said it was working, but I of course tested in 110, and I want to test it exactly in the same way. So I will get my AC source, wait for it to start up, and I have some presets. So I will do 110 60 Hertz, and then we can just do that. It's now 310, so let me do 110 60 Hertz. Connect the plug. Okay, output on. Yeah, and I see a reading. It is on, it's on ohms. So let me put on DC. The bottom digit is missing, but we have a reading. Cool. It has quite some digits in DC on the lower scale. That is actually quite cool. And it's using about 5 watts. That's not that much. Okay, well, I hope I can fix that digit in the bottom. I hope it's just a loose contact. Put it to 1/2 volt. Yes, it does. Okay, how many? When does it switch over? 2. Yeah, okay, 2000 counts. Oh, there is more missing. If this is a 9, there is more missing. Yeah. Yeah, it should now display 88888, and clearly those two are gone. Because if I go to 9, this is still 8, but this one is missing and this one is missing. Yeah, and now it's 9, so now only this one is missing. Okay, well, let's see if we can fix that. Current, if I put 4 milliamps, okay, so the normal M setting seems to work, 5 milliamps. Well, this is almost 4, it's a little bit off. but it does show. So that is just adjusting. Only the milliamps don't work, but I think that probably the fuse is broken because you see it starts blinking and then it cannot get a loop. And here we have the loop. So okay, that works. What about resistance? I hope it can do emulated resistance. Ohms, 20 ohms, does it do that? Yeah, this is always a bit difficult. So this is 0.1k, so this was 100, but also you see it is not locking. This is usually a problem with these older meters, because this is emulated resistance. So let's go a little bit higher. Okay, it is still blinking, that the resistance is also not really getting a loop, but it does respond. It is exactly 1k. I'm not sure if I need to do on the high setting or the low. Apparently I need low. I need to read when I need to change to high. Maybe this is super high impedance. Okay, so that seems to work on the higher resistance, but that is usually normal, that these old meters can't do that. Then you just need a real resistor. So 1k. Why not take the DMM Check Plus, because it is exactly for that. So let's start with 100k. Yes, that is because it is mega 0.1. Look at that. That is spot on. This isn't. These are all 9s. But it looks like a 7, but it's a 9. Okay. Here we go. 10k. That's exactly 10k. $1k. And 100 ohms. Yes, k 0.1, perfect. And now we can do the DC test again with exactly 5 volts. I didn't heat it up, but I do not have so many digits, so it is okay. But preferably you need to keep this for 15 minutes. 5 volts, no problem. Then we go to AC. Switch this one to AC, and we should have, okay, 5 point. This should be 5. Oof, a lot of digits missing. It looks weird. For AC, this is probably not true RMS yet, so AC is a bit difficult. I took out the plug again, and now we're gonna set it to, well, they say normal, and to 230. So let me try to, yeah, that seems to have worked. I can connect now another power plug. Luckily I found a black one, because putting a white one on this would be even super ugly. Okay, I just got the plug. I have here a black, a white and a green. These colors don't necessarily make sense to me. Could be that the green is the earth or the shield, but I'm not sure, and I don't want to make that mistake. So let's open it up and have a look. Keithley usually has just 4 screws in the bottom. Nice colored one, flatheads, and they have the same here. Same nice colors. Okay, we open it up, and I already saw that on most of the ICs it is 74. Only some in sockets. This one is 76, but that is probably replaced. So I think we are correct with that year, around 74. Here is the plug, so we just need to have a look which color does what. 2 fuses here, but that is just for the mains. So then I wonder where is my fuse for the current, and maybe it is underneath here. Usually this area is for AC, they try to shield it. But yeah, well, we need to have a look underneath. Now if we have a look in the top, look at this. Here are the connections and the calibration procedure, battery installation, everything is here. And here say the milliampere to amps fuse replacement. So we need to see where that fuse is, but so there is one. That is good news. Batteries are not here. Here is a connection. It's probably here. And how to connect the plug, DC calibration, ohms calibration, AC calibration. Perfect. Oh yes, indeed, the fuses are underneath the metal. Here it is. Here is one fuse for the amps, and here is one fuse for the milliamps. I'm pretty sure this one is broken because the circuit didn't give a loop. So. Okay, I will just lift one leg from both of them just to see if they are good or not. I'm too lazy to get my proper terminal, so I will just do. Yeah, clearly. Okay, good. So that is why the lower range doesn't work. Fuse is not good. This one is. Well, that's what we expected. It says 200 ohms. So it's also not completely broken, but it is not as it should be. So 100, that would be like 10 milliamps, I think. Yeah, it's also a way of putting it. Well, I need to go through my old stuff because the new I started at 0.2, so that is 200 instead of 10. That is a bit too much. Maybe I have something here or here. So I will have a look. It will be 0.2 then. In this new, check if it is. Don't do this at home because you will blow your meter if you make a mistake. But it is a fast 200 millis. Oh, it is a bigger size. Oh, it still needs to fit because this is a weird size. Okay, well the fuse I will just solder, but I will solder it on, not in the clamp, but just inside, like this. And then when I later find a real fuse, I can just desolder it and can still use the clamp. So that's why I decided to just solder it on the side. Now we're gonna check which one is the ground. So let's say if the green is the ground, we have nothing on the fuse, nothing on the fuse. Okay, it is the transformer shield. Is it shield here? No, no. Okay, that could be. Then we have the black fuses. And this one. 600 ohms on the fuses. That I don't understand, but it is definitely not ground. So now I understand better. Because of this transformer, it's for dual voltage. You put the primary winding in parallel or in series. So both the fuses are both on the positive wire. And so when you measure the negative wire, you measure through the transformer. So now I put it back to 110 and then it is in parallel. So then I have here 300 ohms and 300 ohms. Now I put it to 230, then it becomes in series. and then I have almost 600, and on this one 600. So that means the other one is then completely zero. Yeah, because this is exactly where the fuse is in between, and with the other side you have the windings of this one, and then this one is, yes. Okay, that already looks a lot better. Look at this. Front looks much cleaner. I don't know if you can see better like this. All shiny buttons also. I managed to get most of the text back. Apparently they put with a marker. But that is now better. I didn't want to clean it a lot more because I was afraid that at some point the paint also disappears. But yeah, I think like this is already a lot better. And maybe I need to 3D print some new buttons, or maybe I find some time. Okay, I will put the power plug in the AC source and put the output on, and yes, there it goes. Okay, no problem. Then I can just put it in the mains. Okay, so that is good. If we choose line, here it goes. That digit is still faulty. And I think usually those digits are multiplexed. So I think the steering is good, the driving, I mean, is good. So then probably it's the digit itself that is not okay. And yes, then maybe I need to see if I have them, but they are these very old 7 segments. So if I replace it with the modern one, the color will be different. So I need to see in my old parts. And if I can't find, maybe I put it to the back, because that one is less important. Because I was thinking putting it in the front, because that one only does plus and minus. But because the middle one is missing, I do not have a minus, so that is also not an option then. Okay, I replaced it now to the last digit, so hopefully that is better. Okay, yeah, it moved, so it's clear it is the segment. So I need to find one of those. Okay, I went to the calibration procedure. It just follows step by step. Put your point there, put 100 volts, adjust, etc., etc. It's just word by word, and you just do that. So I did that. So let's have a look at the result. Put this one to 1 volt. 8 degrees, that is nice. Let's go to 5 volts, 503. Okay, well, we can go to 10. Look at that, 10 volts, close to 10 as well. Okay, perfect. Let's see what it does with the current. We didn't even see if that worked. It is out. 4 millis. Let's go to 1 milli, and then we can try the milliamps. It still has problems with the milliamp somehow. Yeah, and here it is 1 milli. Well, it is 1 milli. Look, 1, 2, 3, 9. So it's 10. Let's go to 4. 10 millis. Yeah, perfect. That agrees. It's only weird what happened with the normal, because the fuse was also burned, so maybe they blow up the circuit. Okay, on the ohms, 100k. Well, that is a lot closer already. 10k. Yep. 1k. Here we go, 100 ohms. Cool. Okay, that is cool. They both agree it's almost 1 volt. It is just here switching, and here it is the same. It is 99992. So, yes. Wow, look at that. It is so much cleaner. The buttons are still missing, but they really just broke them off because they didn't want students to use it. I got the letters a little bit back. It's much better to read, but I didn't want to take it out more because then I also need to be careful I don't remove the paint. Now on camera you can really see how transparent the front is. The whole material is made of that display material. And well, I clean of course the covers. I was even able to remove the magic marker that was also on the bottom here. You can hardly see it, but it is still there, but it is a lot better. I changed it to 235 volts, so that is better for here. So I would say almost as it was. Wow, I really like this project again, and it is another Keithley, and every time I'm amazed how it's built, how easy, but also how precise it is still, because I didn't have to do much, and it just did one of the segments, and once I find one I will just replace it. But it's already better that I replace it with the last segment, but that's just because wear. No, it's because it's old. It's almost 50 years. And that is all that I needed to do. Give it a little clean. And well, I do need to check why the milliamps don't work. But all the other functions are working fine, and even super fine. Look at this. Yeah, I liked it. Thank you for watching, and hope to see you next time.